A particle of mass m, m is equal to mass of the particle, and charge q is equal to charge of the particle, and kinetic energy is given by T. Enters a transverse uniform magnetic field B. So magnetic field is B. Magnetic field B. After 3 seconds, the kinetic energy, what will be the kinetic energy? See, already we have seen when a charged particle move in a magnetic field, its work done is equal to zero. Work done is equal to 0, because see here, suppose there is this is velocity, this is direction of magnetic field, this is the direction of motion of the particle having an angle theta. Then by right hand palm rule we move. What is the force? Force is equal to Q into V cross B. So from V to B we have to move with the right hand, the palm rule, right hand palm rule. With V we move this direction. So this is the direction of magnetic field. This is the direction of magnetic field in this direction. So if turn it like this, this will be the direction of magnetic field, which is also direction of V cross B, cross product of vector V and B. So we can see first point, already we have discussed this one. F, magnetic force, is parallel to V cross product of vector V cross B, where V cross B is from this equation V cross B, and this Fm, second point, Fm is perpendicular to magnetic field vector 3. Fm is perpendicular to the plane containing V cross B. This already we have seen in the previous one. This is the plane where V and B are lying, and Fm will be like this, and Fm is perpendicular to V vector, and Fm is perpendicular to vector. Fourth point, we have seen Fm is perpendicular to V vector also. So V vector also, and fifth point, the work done by the magnetic field on the charged particle is equal to 0. That is, work done is equal to force into displacement. That is, dot product of force and displacement is equal to 0. See, Fm is now Fm. This is Fm. This is velocity vector V. The angle between theta is equal to 90 degree. See, the displacement is also in the direction of velocity. It means it is S. This is perpendicular to F vector. It means S also perpendicular to F vector, that is Fm vector. Because what is velocity? Velocity is equal to displacement by time. So whatever is the direction of velocity, the displacement will also have the same direction. It means we can see this is displacement of this one. So with this point we can say F dot S is equal to 0 by work energy theorem. Work done is equal to change in kinetic energy. Here the work done is equal to 0, or we can say kinetic energy. Change in kinetic energy is equal to 0. If change in kinetic energy is equal to 0 means we can conclude. What is change in kinetic energy? Change in kinetic energy is nothing but difference of initial kinetic energy minus final energy. So this we can say change in kinetic energy is equal to kinetic energy final minus kinetic energy initial is equal to 0, or kinetic energy initial final, kinetic energy final is equal to kinetic energy initial. This we can conclude, or half m, this is final means final velocity, is equal to half into m into initial velocity, cancelling this one. So v square is equal to u square, or v is equal to u. This is the second point. Second point, now you see this is speed. It means speed is same, no change in the speed. When a particle is moving in a magnetic field, its work done is equal to 0, and there is no change in the kinetic energy, no change in the speed of the particle. That is, final speed is equal to initial speed, final kinetic energy is equal to initial kinetic energy. What about the velocity? See, in the magnetic field, if the particle is moving like this, its speed is constant. Speed, we can say velocity vector. But how about its velocity? Velocity vector not constant. Why it is not constant? Because at any point, at this point we want to find out the velocity, draw the tangent, this gives the velocity. At this point, this gives the velocity, and at this point, this gives the velocity. It means velocity of the particle is, if you draw a tangent at that point, at any point you want to find out the velocity, draw a tangent at that point, that gives the direction of velocity. It means velocity does not change. Though speed, the velocity changes. That is, velocity change. We have to note it here. Velocity is a vector. Velocity final is not, velocity do not change. Velocity changes at every point. At every point of the path of the particle. Every point at path of the particle. Now, from this we can conclude. For this first question, the kinetic energy of the particle will be. What is the kinetic energy? Because the kinetic energy does not change. Because kinetic energy initial is equal to kinetic energy final. It means there is no change in kinetic energy even after any time. After some time, the kinetic energy at every point, kinetic energy at every point is same. Every point is same. It means what? After 3 seconds also the kinetic energy will remain same. What is the initial kinetic energy? Initial kinetic energy is given by T. So that will be the kinetic energy of the point at any time. At any time, kinetic energy is equal to same. So first point, the kinetic energy of the particle will be after 3 seconds will be same. This is the answer for the first question. Second question, this is first question. And the second question, its momentum changes. What about the momentum? Momentum is a vector is equal to mass into velocity. Since velocity change always, because velocity change at every point of the particle, it means momentum also change at every point of the path of the particle. So by momentum changes, this point we have to note. its momentum changes but kinetic energy is constant. Yes, kinetic energy is constant, which is equal to constant from here because it does not change. So kinetic energy is constant. Okay, here momentum and kinetic energy are not constant. No, this cannot be. Why? Because kinetic energy is constant. So this is not valid point. Potential energy, kinetic energy are constant. No, the momentum is not constant, but kinetic energy is constant. This point also not valid. Kinetic energy changes. Kinetic energy is always same at every point. So this question A is the right answer. That is, its momentum changes, but kinetic energy is constant. These questions appeared in JEE Main 2007. The first question appeared in NEET 2008.